Bill, the renowned scientist, has been captivating us for decades with groundbreaking discoveries and unraveling their complexities. His enthusiasm for space exploration has sparked our curiosity about the unknown as he introduces us to the immense expanse of the cosmos that envelopes us and extends endlessly above. Bill now breaks his silence regarding the most recent images from the James Webb Space Telescope, offering us a peek into a universe over 13 billion years old, drastically reshaping our understanding. 31 seconds of the universe and altering our view on existence itself. This telescope is uncovering new details about faraway planets, galaxies, and much more. It represents a monumental leap in science and stands as a fitting successor to the Hubble Space Telescope. But what exactly makes Webb's images so exceptional, defying our expectations and current theories? And what insights does Bill have to share about them? The creation of this project is the result of years of diligent work from NASA scientists and engineers, with its launch taking place 1 minute and 4 seconds on Christmas Day in 2021. The various stages of the telescope's deployment went off without a hitch over the following months. By June 2022, scientists began to observe thousands of newly discovered galaxies, some of which are older and farther away than previously known. Some of these galaxies could have formed up to 150 million years before Hubble's earliest discoveries. Additionally, the telescope has the ability to capture enough light from celestial objects like exoplanets and stars, revealing details about their 1 minute and 37 seconds composition and their paths through space. According to Bill, this data is already offering profound insights into the atmospheric makeup of planets located light years from Earth, allowing scientists to make informed guesses about their ability to sustain life as we know it. One of the Hubble Space Telescope's most iconic images has long been the Pillars of Creation in the Eagle Nebula. This structure was visible through Hubble, which primarily detects visible light, but the processes occurring within it were not fully 2 minutes and 6 seconds understood. The Webb Telescope, with its infrared capabilities, has provided a deeper view of the nebula, revealing numerous protostars. These appear as clusters of gas and dust, each several times the size of our solar system, marked by small red dots against the backdrop of the pillars. Bill notes that these stars aren't yet burning hydrogen. As material accumulates toward the center of these forming stars, it becomes increasingly dense, eventually triggering hydrogen burning, which causes a dramatic rise in temperature to around 2 million. 2 minutes and 41 seconds degrees Celsius. Two distinct colors in the infrared image reflect wavelengths invisible to the human eye. The only visible parts of the image appear blue, with hues intensifying the red radiation. As the protostars emit radiation at a wavelength 6 times longer than what we can see, Bill suggests that this image not only highlights the Webb telescope's infrared capabilities but also sheds light on the process of star formation, similar to that of our own Sun. Exoplanets were first discovered in the 1990s, and today, over 3,000 planets are 3 minutes and 14 seconds confirmed to orbit distant stars. However, only a fraction of them have been directly imaged. Most exoplanets are too far away to be seen directly, only detectable when their star's light is dimmed by their presence. The first direct image of an exoplanet was captured last year. This planet, named HIP 65426b, was identified in 2017. Scientists used coronagraphs on telescopes to block out the light from the central star, combined with 2 of Webb's cameras and a set of filters, to observe the planet. This exoplanet is 3 minutes and 50 seconds. Notable for its outstanding infrared sensitivity and its great distance from its star, 100 times the distance between the Earth and the Sun. It's a massive gas giant, nearly 12 times the size of Jupiter. The ghost galaxy, though faint in the sky, can be captured with infrared cameras. The spiral shape of the galaxy, with its stars radiating from the center, is visible in optical images, often referred to as M74. However, the latest Webb telescope images show additional features, like filaments of heated dust and gas. 4 minutes and 25 seconds. Emanating from a bright core, captured in striking electric blue. This new view will help illuminate areas where stars are forming within the galaxy's spiral arms. Combining Hubble and Webb Space Telescope images, researchers have created a composite image that merges optical and infrared views of the galaxy. This composite was produced by researchers from the European Space Agency, ESA, as part of the PHANGS project, which observes 19 nearby galaxies using Webb, Hubble, and various ground-based telescopes in infrared wavelengths. 4 minutes and 57 seconds. Thanks to Webb's precise observations, astronomers can now identify star formation areas in galaxies, accurately measure the ages and masses of star clusters, and study the properties of minute dust particles drifting through interstellar space. In an image of the distant star Wolf-Rayet 140, taken last July, a recognizable diffraction pattern was seen. However, the star is also surrounded by unusual wavy, concentrated rings with a square-like appearance. These rings, unlike the typical diffraction pattern, are characteristic of 5 minutes and 32 seconds. Massive stars known as Wolf-Rayet stars, which are nearing the end of their lives and have already expelled large amounts of hydrogen. The interaction between WR-140 and a smaller companion star gives rise to these distinctive ring shapes. The Webb Telescope is designed to observe the most distant galaxies in the universe. In mid-December of last year, researchers reported the discovery of 4 of the oldest known galaxies. These galaxies, seen for the first time by Webb, date back 13.4 billion years, when 6 minutes and 3 seconds. The universe was only 350 million years old, or about 2% of its current age. These 4 galaxies were once thought to be extremely old, similar to many other galaxies Webb has discovered. Researchers used the James Webb Telescope's capabilities to measure their distance, determining their age through redshift, which measures the stretching of light wavelengths caused by the universe's expansion. The largest redshift ever recorded was 13.2, and these newly discovered galaxies exceed even the predictions of 6 minutes and 33 seconds. Astronomers before Webb's launch. For the first time, we can pinpoint galaxies from this early era and spectrographically verify their immense distance. Meanwhile, Webb has also studied a planet in the Virgo constellation named WASP 39b. This planet is located about 700 light-years away, orbiting its star 8 times closer than Mercury is to the Sun. A gas giant similar in size to Saturn, WASP 39b has an atmosphere thick with sulfur and silicates, including sulfur dioxide. Using Webb's spectrographs, scientists were able to detect carbon dioxide in its 7 minutes and 10 seconds atmosphere, further enhancing our understanding of distant exoplanets. The launch of the James Webb Space Telescope marks a new era in space exploration, where the boundaries of our knowledge are constantly being expanded. Bill, along with countless scientists and engineers, continues to marvel at the way this cutting-edge technology has transformed our understanding of the universe. The Webb Telescope isn't just a tool for observing distant stars and galaxies, it's a monumental leap forward in. Bill takes a deep breath, his excitement evident as he gestures toward the latest images projected on a large screen behind him. These breathtaking visuals, captured by the Webb Telescope, serve as a testament to the sheer scale and complexity of the universe. As we continue to analyze Webb's data, Bill explains, we're not just looking at distant stars and galaxies, we're looking back in time, witnessing the universe in its infancy. And with each new discovery, we gain more insight into the forces that shaped everything we see today, including our own existence. One of the most recent breakthroughs involves the detection of a massive galaxy cluster, located over 12 billion light-years away. This cluster, named WHZ 274, appears to be one of the earliest large-scale structures in the universe. The gravitational lensing effect of this cluster has allowed scientists to magnify even more distant galaxies beyond it, revealing formations that were previously invisible. Some of these galaxies existed just a few 100 million years after the Big Bang, offering an unprecedented view of the universe's first generations of stars. 14 minutes and 30 seconds. Bill points to another image, this one showcasing a distant exoplanet with swirling cloud formations. This is Kepler 442b, he says. A rocky planet located about 1,200 light-years away, it sits within its star's habitable zone. What's particularly exciting about this planet is that Webb has detected water vapor in its atmosphere. Scientists are still analyzing the data, but the presence of water vapor suggests that Kepler 442b might have the right conditions to support life. In addition to water, Webb's instruments have detected traces of methane and carbon dioxide, both of which could indicate geological or even biological activity. If we confirm biosignatures, chemical signs of life, on a distant exoplanet, it would be one of the greatest discoveries in human history, Bill says. And this is just the beginning. 15 minutes and 15 seconds. Beyond exoplanets and ancient galaxies, Webb is also shedding light on some of the universe's most mysterious forces, dark matter and dark energy. Using gravitational lensing techniques, scientists have been able to map the invisible influence of dark matter within galaxy clusters. This research is helping to refine our understanding of how galaxies form and evolve. Meanwhile, Webb's ultra-deep field observations are providing new insights into dark energy, the mysterious force driving the universe's accelerating expansion. Some astronomers believe that by analyzing the way distant galaxies interact, we may eventually unlock the secrets of this elusive phenomenon. 15 minutes and 55 seconds. Bill leans forward, his eyes gleaming with anticipation. Every time we think we've reached the limits of our understanding, Webb surprises us. It's opening doors we never even knew existed. As the briefing comes to a close, Bill leaves the audience with a powerful message. We are part of something much bigger than ourselves. The more we explore the universe, the more we realize how interconnected everything is. Webb is not just a telescope, it's a time machine, a storyteller, and a key to understanding our place in the cosmos. As he steps back from the podium, the room erupts into applause. The journey of discovery is far from over, and with each new observation, humanity takes another step toward unraveling the greatest mysteries of existence.